What color is the ocean? This is the first question that we all ask ourselves about the ocean. A second question is why the ocean sometimes appears dark blue, light blue, green, or red. From a child going to the beach to an oceanographer, these are the questions they ask themselves. Firstly, let's define what we mean by ocean color. Ocean color refers to the hue and intensity of light reflected from the surface of the ocean. This color is influenced by the properties of the water itself, including the amount of dissolved and suspended materials, as well as the presence of living organisms such as phytoplankton. The color of the oceans can vary depending on several factors such as the amount of sunlight, the depth of the water, the number of particles and organic matter in the water, and the presence of microscopic plant-like organisms called phytoplankton. Typically, the open ocean appears as shades of blue, ranging from light blue to dark navy blue. A more important question arises in our minds as to why we often perceive the ocean as blue. One of the main reasons the ocean appears blue is the color of the sunlight. Sunlight contains a spectrum of colors, ranging from violet to red. When sunlight enters the Earth's atmosphere, the shorter, bluer wavelengths of light are scattered more than the longer, redder wavelengths. This is known as Rayleigh scattering and is why the sky appears blue. When this blue light enters the ocean, it is absorbed by the water, giving it a blue tint. Why are some blues dark and some blues light? Due to the depth of the ocean, we perceive the ocean as dark blue at times and light blue at other times. When light enters the ocean, it is absorbed by the water molecules and particles in the water. Blue light, which has a shorter wavelength, is absorbed more quickly than other colors, which is why the ocean appears blue at the surface. As you go deeper into the ocean, the water absorbs more and more of the blue light, making the water appear darker. It is for this reason that satellites' images can be used to estimate the depth of water. The green and red colors, however, are natural and indicate a biological activity taking place in the ocean. One of the key drivers of ocean color is the presence of phytoplankton. These tiny, plant-like organisms are found throughout the world's oceans and are essential for sustaining marine ecosystems. Ocean food chains begin with these organisms. Phytoplankton also plays a crucial role in regulating the Earth's climate, as they absorb large amounts of carbon dioxide from the atmosphere. When phytoplankton is abundant, they can give the ocean a greenish tint. This is because they contain pigments, such as chlorophyll, which absorb blue and red light and reflect green light back to our eyes. Scientists use satellites and other instruments to measure the amount of chlorophyll in the ocean, which helps them to track changes in phytoplankton populations over time. For this reason, oceanographers use this color to detect biological activity on the water's surface. There are a few reasons why the ocean may appear red, but one of the most common causes is the presence of a phenomenon known as red tide. A red tide is a type of harmful algal bloom that occurs when certain species of algae grow and multiply rapidly, leading to a discoloration of the water. Red tide is caused by the production of pigments by the algae, which give the water a red or brownish tint. Nutrient pollution from agricultural runoff, sewage, and other human activities can exacerbate the growth of these algae, leading to more frequent and intense red tides. Climate change may also play a role, as warmer waters can create more favorable conditions for the growth of these algae. In addition to these factors, other factors can also play a role. For example, dissolved organic matter, such as tannins from decaying plants, can give the ocean a brownish tint. Suspended sediment, such as mud and sand, can also affect ocean color, making the water appear cloudy or murky. In conclusion, ocean color is a fascinating and important topic for understanding the health and dynamics of our oceans. From phytoplankton and algal blooms to climate change and carbon cycling, ocean color research has many practical applications and can help us to better understand and protect our planet.